So, a very good morning to all. Right. Okay. Uh, okay. Now let's start with the today's session that we are going to today. Today is our PYQ day. So today we are going to solve some question related to aldehyde and ketone only. Right. In previous class, we discussed about the coordination chemistry. So this class is for only aldehyde and ketone. So we are going to discuss some important PYQ which are very important and try to solve this question and try to practice as much question as you can, right? So let's start with the today's session. Okay. So what is the first question here now? The first question is that is out of these two statements, you have to identify which statement is true and which statement is false. So what is the statement, beta? According to statement number one, that is assertion, that is acetal ketal is a stable in a basic medium, right? If I'm talking about acetal and ketal, it is stable in the basic medium. So what do you mean by this term acetal and ketal? We all know that now, that is ketone, or we say aldehyde, that is carbonyl group, react with alcohol, right? React with alcohol to form this acetal or ketal group. First of all, in the first step, formation of hemiacetal takes place, and in the second step, the formation of acetal takes place, right? For example, if I'm talking about hemiacetal, then what happened now? This will, if you consider aldehyde group here, that is CH3, CHO, and react with ROH, then what product will be formed? Tell me first, what product you'll get? So that is OH, OR, and this is CH3 and H. So the formation of hemiacetal takes place. So in question one, their statement one, they are asking acetyl ketal is a stable in basic medium, right? And second, what is the reason of behind this? That is the high leaving tendency of alkoxide ion give the stability to acetal or ketal in the basic medium. So let's see whether it is true or wrong. Okay. So here the assertion na, that is acetal and ketal are basically ether. Okay. तो ये देख लेना तुम लोग एक बार. Acetal and ketals are basically ether. Hence they must be stable in the basic medium. Okay. We know that ether like compound are more stable in basic medium but should break down in acidic medium. Hence we can say assertion is very much correct, right? Because the acetal and the ketal are basically ethers and they must be stable in the basic medium. Now if I'm talking about what is the reason for this question now, that is alkoxide ion is not considered as a good living group, hence reason must be false. Okay, so this reason is not up to the mark. Hence, what is the correct answer for this question is that is A is true, but R is false. So the correct option is A, right? Okay. Shall we move to the next question? Okay. Now, in this question, basically, you have the match list one with list two. So in the first list, some name of the important reactions are given, right? Like Hopman's degradation, Clemson's reduction, Cannizzaro reaction, and RTM. Okay, and in list two, you have a reagent. Which reagent is used for the such kind of reactions, right? So if I'm talking about the Clemson's reduction or Hopman's degradation, what reagent is used in Hopman's degradation? Basically, Hopman's degradation is used in the preparation of what? Amine. Okay. And as the name suggests now, Hopman's degradation. It means in this, number of carbon atom is decrease, or we say that it is the type of reaction in which the chain of the carbon is decreases, right? So which reagent is used in Hopman's degradation, beta? That is Br and NaOH. As the name suggests, Hopman's bromide degradation. So we use bromide here. We use some strong base like KOH or NaOH, right? So what is the correct match list for the A is third. That is Br2 and NaOH. That is A with third. It means option number A and option number 3 remains out of option 2 and option 4 is eliminated. So just eliminate this two option, right? Okay. Now, the next one is Clemson's reduction. We all know what is Clemson's reduction basically. Clemson's reduction in which aldehyde or ketone, when treated with zinc amalgam in presence of HCl, the formation of alkane takes place, right? So, which one is the correct region for the Clemson's reduction, beta? That is option number 4, right? That is zinc amalgam and HCl. So, the correct for B is 4. Okay. So A 3 and B 4. Okay. Next, move to the next question. That is Cannizzaro reaction. So we know that for Cannizzaro reaction, as the name suggests, always remember this word. That is Cannizzaro. Cannizzaro means what? That is concentrated NaOH or KOH. Must we use concentrated? If the question related to aldol condensation, then you have to use dilute base. But this is Cannizzaro. Cannizzaro reaction are those reaction which undergo only those aldehyde having lack of alpha hydrogen, and aldol condensation are shown by those aldehyde which having alpha hydrogen. So these are the basic requirement for the Cannizzaro and aldol condensation, right? Okay. So, Cannizzaro reaction, what's the reason used? That is concentrated NaOH. That is C is equivalent to 1. So, which one is the correct? Yes, beta. That is option number 3. And last but not the least, that is RTM. So, for RTM, what we use? That is chloroform in presence of some base. So, this is the required answer for this question. So you learn a lot from this question, because this question consists of several name reaction, and you must remember all this name, and it's going to be very useful, because many times questions are coming asking about the regions or the what the product form, which form is major or which is minor. So please try to remember this as well. Okay, now let's move to the next question. Yeah, that is a tri-substituted compound A, that is C10H2012O2, gives a neutral FeCl3 test positive, right? Now, a tri-substituted compound, one important note here, like C10H12O2 gives neutral FeCl3 test positive. Treatment of compound A with NaOH and CH3Br give C11H14O2 with hydro acid. Give methyl iodide with the hot concentrated NaOH. Give compound B. Now, compound A also decolorize alkaline KMNO4. Now, you have to calculate the number of pi bonds. तो यहाँ पे क्या क्या तुम लोगों को एक मेन की क्या दे रखा है, जैसे तुम इसे आइडेंटिफाई कर सकते हो. तो सम ऑलवेज क्वेश्चन ना ऐसे क्वेश्चन होते हैं जिसमें कुछ ना कुछ की हम तुम्हें ऑलरेडी मेंशन होगा, जिसको यूज करके तुम यूटिलाइज कर सको, राइट? So in this first key is tri-substituted compound. Now it gives FeCl3 test also. So ये test भी दे रहा है. Now treatment of this compound A with NaOH and CH3Br give C11H14O2 with the hydroic acid give methyl iodide with the hot concentrated NaOH. So let's see the solution for this question. So yeah, this is C10H12O2, right? And this react with CHO plus 3 C3H7. Both group can be present. It means in this CHO plus C3H7, both group are present. Or we can say that now, that is, this will be either be phenol, that is CH2OH, or C double bond C CH3, both group can be present, right? So when we treat with NaOH and CH3I, what the product you will get now? That is, what is A here, beta? That is this one. Okay, so this is our A. It must be phenol, right? So this is your correct answer, right? Because we know that out of alcohol and phenol undergo FeCl3 test, and the formation of violet color complex takes place, right? So in this, both phenol as well as that is CHO group will be present, right? Okay. Now move to the next question, that is number of isomeric compound with the molecular formula C9H10O which do not dissolve in NaOH. And the second point, do not dissolve in HCl. And the third point, do not give orange precipitate with 2,4-DNP test. And the fourth one is on hydrogenation, it give identical compound with the molecular formula C9H12O. Now you have to calculate the number of isomeric compound, right? With the molecular formula like this. Now, as per the language of the given question, the best possible isomeric structure is that is phenyl CH CH3, that is cis and trans. So there is a two-way, that is either cis or trans. So total number of isomeric compound form will be 2 beta. Okay? So just remember this. What is the structure for this? Like phenyl group, like this. Okay. And CH double bond CH OCH3. Right? So this will form either cis and trans. So the correct answer is 2. So total number of isomeric compound with the molecular formula C9H10O is right. Okay. Now, which of the following is an example of conjugated diketone? Okay, so you have to identify which one is conjugated diketone. So out of this four option, just identify conjugated diketone, right? So just identify this. What is conjugated system here, beta? Conjugated system is basically electrons are delocalized with alternative single and double bond. Okay, so conjugated ketone has a CC, that is C double bond C unit attached directly carbon to the carbonyl group, right? So out of these four options, in which this for principle is followed, out of this four option, beta. Yes. That is option number C. So option C is the correct answer for this. That is conjugated diketone. It means they having alternate double and single bond and methyl group. And the conjugated ketone has a CC unit attached directly to the carbon of the carbonyl group. Right? So a correct option is C. This is from conjugated diketone. Right? Okay. Now, next, move to the next question. That is, which of the following conditions or reaction sequence will not give acetophenone as the major product, right? So, which of the following condition or reaction sequence will not give acetophenone as a major product? We have a four option like A, B, C, and D. Okay, you have to identify which of the following condition or reaction sequence will not give acetophenone as a major product, right? So, how will you remember this, beta? Let's see the mechanism behind this question, right? So if I'm treating benzaldehyde, right? Benzaldehyde with Grignard region, we know that in Grignard region that is R, Mg, and X. So R act as a nucleophile, where this will act as a yeah, that is negative charge act as a nucleophile, positive charge act as a electrophile, right? So these we know that O is a more electronegatives as compared to carbon, so they try to take away the electron from the carbon, and to support this methyl group comes into the picture and they support carbon because methyl group act as a nucleophile, right? So the formation of this takes place. Now when we treat with Na2Cr2O7H plus now, then the formation of what takes place, beta? Acetophenone, right? Then the formation of what takes place, that is acetophenone. So which of the following condition or reaction sequence will not give acetophenone? So in this acetophenone is produced. Okay, now next move to the next question, that is this is I'm talking about CH3CHO, that is in case of aldehyde. Again this phenomena takes place, and we know that in presence of PCC and DCM. PCC is basically used so that this compound remain to aldehyde or ketone group only. Their oxidation will prevent it, not otherwise they are converted into carboxylic acid, right? So in this also acetophenone is produced, right? So in this also acetophenone is produced. What is acetophenone, beta? Na? Just yeah, that is the COCH3. So this is the structure of acetophenone, right? So in the above two options, acetophenone is produced. Let's see the third option. That is C6H5COC2H5, and we react with this CH3MgBr. In this also, the formation of acetophenone takes place, right? So this is also true. Okay. Now, in this, just observe carefully whether it is acetophenone or not. Yeah, this is acetophenone. No. Okay. So in this, the formation in the fourth option also, na acetophenone is produced. So out of this four, that is A, B, C, D, only in option number C, that is acetophenone does not produce. So what is the correct answer for this question, beta? That is C. That is in this, the acetophenone is not produced as a major product. Right? Okay. Now, which will have the highest annual content? You have to identify out of these four options, which will have the highest annual content. Okay. So, which will have the highest annual content, beta? Out of these all, fourth option, enol form. You know what is enol form? Yeah. Enol form like what? We have a form like enol form or enol form. So different kinds of form we have, like. So which will have the highest enol content out of this four? So just look the option number C, that is this one. Okay. Okay. So this one is a tautomer of this. Yani it means which is aromatic in nature, right? So this is that is option number C because it will form aromatic compound and aromaticity we know that it is much more stable. So which will have the highest enol content beta? That is option number C. So this will contain highest enol form, right? Now the final product A in the following reaction. So you have to identify the final product in this reaction, right? So let's okay. Hmm. So what is the final product beta? Please try to solve this. In this ketone, we have a ketone group, right? Like C double bond O, CH3 and CH3, CH2. And this will treated with SCN, right? This will treated with SCN. We know that this is the which type of reaction is this? This is the nucleophilic addition reaction. Okay, without elimination. Because in this CN act as a negative, NH act as a positive. So what happened now? We know that this will have negative charge, this will having positive charge. So positive, this H goes to this oxygen atom and CN goes to this carbon atom. So what's the product form beta? That is C, CH3. This is CH3 again. This is CH2 and this is the CN and this is OH. So this is cyanohydride, right? So this formation of cyanohydride takes place. Now this cyanohydride again treated with 95% H2SO4, H2SO4 and then heat. Okay, so then this is heated with 95% H2SO4 and then heated. So what the formation takes place, right? So just observe it very carefully. Here the cyanohydride takes place and when heat this, then this molecule, right? This molecule that is OH, this OH will remove, right? So the formation of what takes place, beta? This one. That is option number A. So option number A is the correct option for this question, right? So this follow nucleophilic addition reaction mechanism. So just to remember this, and after this we treat with H2SO4 and just heat this. Okay, so removal of one water molecule takes place. Is it clear to everyone? Right. Now, in the given reaction, the number of pi electron present in a product P is, okay, in the given reaction, the number of pi electrons present in the product P is. So number of pi electron you have to calculate in the product. Okay. So what happened? For example, if you considering this equation, in this it is treated with some base, strong base, or we say then we heat it, then the major product P is formed. Now in this product, you have to calculate the number of pi electrons. So let's see. Okay, so in this you have to calculate the number of pi electrons. So how many pi electron it having? Yes, try to calculate the number of pi electrons. We all know that single bond containing only sigma bond, double bond containing one sigma and one pi bond. So you have to just calculate the number of pi bond here. Okay, so how many pi bond are here, beta? That is 4, right? So number of pi bond is 4. So just calculate this, right? Okay. Now, let's move to the next question. That is, we have a two statement, that is statement 1 and statement 2. Statement 1 state that the nucleophilic addition of sodium hydrogen sulfide to an aldehyde or ketone involve a proton transfer to form a stable ion, right? Statement 1 state that the nucleophilic addition of sodium hydrogen sulfide to an aldehyde or ketone involve a proton transfer to form a stable ion. Statement 2 state that the nucleophilic addition of hydrogen cyanide to aldehyde or ketone is amine as a final product. Is it, is it true? The nucleophilic addition of hydrogen cyanide, that is, this is aldehyde, right? This is aldehyde or ketone, no issue. And when this treated with SCN, then what takes place, beta? We already discussed now. In this, the formation of cyanohydrine takes place, right? Cyanohydrine. So, statement to state that the nucleophilic addition of hydrogen cyanide to an aldehyde or ketone give amine as a final product. Is it true? And the first statement is that nucleophilic addition of sodium hydrogen sulfide, right? Sodium hydrogen sulfide like CO, and it is treated with sodium hydrogen sulfide. It means NaHSO3. Okay. So in this also the formation of that is ONA, SO3Na and OH. Right? SO3Na and OH formation takes place. So out of these three, which statement is correct? So statement 1 is absolutely correct because in this the formation of OH and SO3Na takes place, and which is white crystalline, that is soluble precipitate. Okay? Okay. Now, if I'm talking about statement 2 now, then in this the cyanohydrine formation of cyanohydrine takes place, not amine is formed. Right? So which one is the correct option out of the two? That is statement 1, statement 2. The statement 1 is absolutely correct, where statement 2 is not the correct answer for this question, right? So just remember this, because in this na cyanohydrine formation of cyanohydrine takes place, not amine. But as according to the statement 2, they are saying nucleophilic addition of hydrogen cyanide to aldehyde or ketone give amine, which is not correct. Okay. As we see, when the aldehyde or ketone is treated with cyanohydrine, then the formation of what, beta? Then the formation of cyanohydrine takes place, not amine. And similar in statement 1, it states that the nucleophilic addition of sodium hydrogen sulfide to aldehyde or ketone involve proton transfer to form a stable ion, and this is absolutely correct. Okay, so the correct option for this question is option number 2. That is statement 1 is correct and statement 2 is incorrect. Now, next move to the next question, that is experimentally reducing a functional group cannot be done by which one of the following reason. So experimentally reducing. So out of the four option, which will does not reduce the functional group? It means experimentally reducing a functional group cannot be done by which one of the following reason. The first one is PT, CH2, NH2, PD in presence of CH2, or ZNH2. Okay, so just remember this beta, NaH2. In case of sodium hydrogen, these are the experimentally reducing a functional group cannot be done by this reason. Okay, so the correct answer for this question is NaH2, right? So any solution of NaH2 is not a reducing agent. Just remember this. Solution of NaH2 is not a reducing agent. So this is simple question, I guess. Okay, now this is important questions. Okay, so what the question asks, beta? In this question, we take an acid chloride and we treat this acid chloride with alcoholic ammonia followed by NaOHBr2 followed by NaNa2 plus HCl and last H2O. And you have to identify the major product. So we have a four step of reaction. Like first step, you have to treat with this alcoholic NOH3. In second step, you have to treat with this NaOH. In third step, you have to treat with this with NaNO2HCl, right? So, what is the major product? So, let's see the solution in a detailed way. That is when this treated with alcoholic NaOH3, then the formation of amide takes place. We know that whenever RCOCl is treated with ammonia, right? Whenever the RCOCl is treated with ammonia, then the formation of RCONH2 takes place. That is amide, right? So in this also, same phenomena taking place, that is amide. Now this amide is treated with NaOH-Br2. As the name suggests, Hofmann's bromide degradation, we already discussed. When the amide is treated with Br2 plus KOH, this is known as Hofmann's bromide degradation. Then the formation of what takes place, beta? That is CH3, CH, CH3, CH2, CH2, and this is NH2. That is amine. Now this amine is treated with NaNO2 and HCl. Like 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 जैसे हम लोग पढ़ते थे ना बीडीसी रिएक्शन बेंजीन डिसोनियम क्लोराइड का, तो डाइसो कंपाउंड का फॉर्मेशन, तो उसी तरीके से दिस रिएक्शन आल्सो टेकिंग प्लेस इन एलिफेटिक अमाइन एज वेल, राइट? नॉट ओनली एरोमेटिक अमाइन, एलिफेटिक अमाइन एज वेल, डाइसोनेशन ऑफ एलिफेटिक अमाइन. Then the formation of what takes place, beta? CH3, CH, again CH3, this is CH2, CH2, and what? That is NCl, right? NCl. And last but not the least, we know that when we treat this with H2O, then the formation of alcohol takes place, right? So this is very, very important question. You know, it include almost four different reactions. That what happened when the acid chloride is treated with the ammonia, what happened when the amide is treated, what happened when the amine is treated with the NaNH2Br2. So these involve almost four different type of reaction. On the similar basis, now I'm going to share one important question with you also. On the similar note, if the question asks like, what happened when this will COCl is treated with ammonia, then the formation of what takes place, beta? That is what? That is amide, right? Okay. On the similar basis, if there's a question asked like, what happened? This is CONH2, right? Now, this CONH2 again treated with the Br2 and KOH to form aniline. Now, this aniline, when treated with the NaNO2, NaNO2, and HCl, this is called dissonation. And the formation of what takes place, beta? That is N2Cl. That is N2Cl. And this N2Cl, when treated with the H2O, then phenol. Then the formation of phenol takes place. Right? So, from BDC, there are several product forms. So just whenever some questions are coming related to this, whether hydrobenzene is formed, chlorobenzene is formed, phenol is formed, or we say chlorobenzene, or we say only benzene is formed, always try to use this concept. Like first of all, you need to prepare BDC. Once you prepare BDC, then you can able to go to the many way like benzene, phenol, chlorobenzene, and all. We are going to see this all in our next chapter, that is amine chapter. We are going to study this, that how will you prepare many different products by using BDC, right? Okay. So shall we move to the next question? Is it clear to everyone? Yeah. Now, in this question, what is the major product formed in the following reaction? So according to this question, they are asking the major product formed in the following reaction. Okay. So you have to identify. So first of all, which type of reaction is this, beta? Yeah, this is in this CH3CHO. It means CH3CHO, and this will treated with what, beta? This will treated with the OCH3, right? This is CHO, CH3. This is like O and CH3. Okay. Now, and this is with dilute NaOH. We know that Whenever dilute NaOH is present, always go for aldol condensation. Just check whether it is alpha hydrogen or not. Yeah, it having alpha hydrogen, so it will undergo aldol condensation, right? So, beta, what is the reaction mechanism here? That is this one, that is COCS3. Okay, this is basically ketone group, right? And this ketone undergo aldol condensation to form this product. Okay, so what is the final product here, beta? We know that in aldol condensation, the formation of what takes place, beta, just a beta hydroxy. That is beta hydroxy, or we either it will be aldehyde or ketone, right? So formation of beta hydroxy, aldehyde or ketone takes place, right? So this is the desire, this is the desired one in this question, right? This is the desired product we get in this question, beta hydroxy. So just look here, in which beta hydroxy aldehyde or ketone formation takes place, beta. Just observe it carefully. That is option number 3, right? Here, this is a group. Okay, so this is a group. So this is the alpha carbon, right? So this is a group here. So this is the alpha carbon. This is beta carbon, right? So this is alpha carbon. This is beta carbon. So beta position hydroxy. So beta hydroxy, and whether it is aldehyde or ketone doesn't matter. So formation of beta hydroxy is indicate that this will undergo aldol condensation. So always remember this aldol condensation. Unless we heat this, we get the beta hydroxy aldehyde or ketone. After heating this, we get the enol form, right? Okay. I hope is it clear to everyone? Have any doubt, beta? No? Shall we proceed with the next question? Yeah. Now, the major product of the following reaction is, you have to identify the major product of the following question. In this, when they are treated with NiH2 in the presence of some reducing agent, what the formation takes place, right? So this is having ethyl group and this is having cyanide group. This is ethyl and this is cyanide. And this is treated with the reducing agent. So what takes place, beta? That is, whenever this is treated with NiH2, then what? Then the reduction of cyanide takes place. That is, CN is converted into NH2 and NH2. Now, when this is treated with the dival H, then this reduction of ethyl group, that is OET, takes place, and this formation of double bond O and NH2 NH2. After the removal of H2O, the final product is like this. It means Ni and H2 is used to reduce cyanide group, and dival H is used to reduce the ethyl group, that is OETH. Okay, so it is used to reduce the ethyl group as well, right? And after the removal of H2O, what will get, beta? Will get the structure like this. That is option number 4. This is absolutely correct, right? So this is the correct answer for this question. Okay, now let's move to the next question. That is CH3, CH2, CHOH, PH, CH3 cannot be prepared by. Okay, this cannot be prepared by out of this 4 option. You have to identify out of this 4 in which way this cannot be prepared by. So, as we see now, tertiary alcohol is prepared by the reaction of Grignard reagent with ketone. That is formaldehyde used to prepare only primary alcohol. So this is what? This is the tertiary alcohol. So tertiary alcohol is used, is prepared mainly from the ketone with the what? We know that, just remember one important concept here, beta. That is when the formaldehyde, right? When the formaldehyde is treated with Grignard reagent, then primary alcohol will form, right? Similar way, when the aldehyde is treated with Grignard reagent, then secondary alcohol will form. And when the ketone is treated with Grignard reagent now, then tertiary alcohol produce. Right? Just remember this. So in this question, this cannot be prepared by. So this is a 3-degree alcohol, right? So 3-degree alcohol can be prepared by tertiary, sorry, ketone. So just identify that is CH3, CH2, COO, CH3, PSCO, CH2, CH3, CH3. This is. So this one, that is option number 4, because when you treat with SCHO with this compound, na, then the formaldehyde never produce tertiary alcohol, right? Formaldehyde is used to prepare primary alcohol only. So this is the primary alcohol. So option number 4, that is this one. Formaldehyde is not used for the preparation of tertiary alcohol, right? Is it clear to everyone? Okay. So I hope is it clear to everyone, right? Okay. Now this is also very important question. These all questions were coming in a previous examination, right? I'm taking mostly last 5 years questions, and including all topics like that. Okay, including all the topics which are really repeated topics, like many times questions are coming such topics. Only those topic I'm covering here. So these are the very important session. Please try to learn this and utilize this, okay, so that you are able to solve questions as well. Now, in the following reaction, when the aldehyde is treated with alcohol in presence of HCl, then the formation of acetal takes place. This is absolutely correct, right? Like aldehyde, for example, if I'm talking about aldehyde, this is aldehyde and this is treated with alcohol. Alcohol means what, beta? That is ROH. Then the formation of what takes place? That is C. This is O. Yes, this is OR and this is OH. This is called hemiacetal. Again, when we treat with ROH, the formation of acetal or ketal takes place. That is OR and OR. Right. So this is acetal. Okay. Now, the best combination is, because here the aldehyde is given, that is SCHO and CH3CHO, and acetal alcohol is also, that is alcohol with BuOH or MeOH. So you have to identify the best combination is there. Which one is the best combination? So best combination is SCHO, because SCHO is a more reactive aldehyde. We know that out of these three, that is formaldehyde, and again aldehyde, and again ketone, right? So out of these three, that is formaldehyde, aldehyde, and ketone, which one is more reactive, beta? Obvious. Formaldehyde is more reactive, right? Why formaldehyde is more reactive? Because it having less plus I effect creating group, as in aldehyde and ketone. Here only one, here two plus I effect creating group. So as the plus I effect creating group increase, right? As the plus I effect creating group increase. So as the plus I effect creating group increase, reactivity decrease, or we say more reactive is aldehyde. Out of ketone and aldehyde is more reactive. Similar out of aldehyde and formaldehyde, formaldehyde is more reactive, right? So best combination is HCHO, because it is more reactive aldehyde, and methyl hydroxide. Why? Because it is a less strictly hindered alcohol. So this formation, that is OR now. So this will be the best possibility, that when the formaldehyde, like this one H and H, and this is treated with the CH3OH, right? CH3OH in presence of acid. So what formation takes this, beta? That is H, that is H, this will become OMe, and this is also OMe. So this is the best possibility or a best combination. So what is the correct option for this question, beta? The correct option is 2. Okay, so that is option number 2 is absolutely correct for this, right? I hope you understand this. Okay. Okay, beta. Just try to solve this question. Yeah, question number 13. Just try to solve this. Yeah. Just try to solve this question. Question number 30. Okay. Okay. So what's the question number 30? 13 ask beta. Next question. Yeah. So according to this question, what is the major product of the following reaction? So you have to calculate the major product of the following reaction, right? So what is the major product for the following reaction, beta? When this is treated with NaBH4 and ethyl alcohol. So the reaction is with NaBH4 and ethyl alcohol. You just identify the major product for the following reaction, right? So let's see. Okay, now NaBH4, here one important note here, na beta, that is NaBH4 does not reduce the double bond, but can reduce the keto group into OH group. So this must be noted, beta. It's very, very important point to note, that is NaBH4, right? NaBH4 does not reduce, right? NaBH4 does not reduce the double bond, does not reduce the double bond, right? Okay, that is NaBH4 does not reduce the double bond, but but can reduce, can reduce keto group, right? Keto group. Okay, so keto group into what? Keto group into OH group, right? Keto group into OH group. So this is the important note here, beta. So what is the correct for this? That is question number 2, right? That is NaBH4 cannot reduce the double bond, but it can reduce O into OH. So this is the only option you supposed to be right? Because in option A, 3 and 4, double bond is also reduced, but NaBH4 having tendency to reduce only keto group, that is keto group into OH group, not the double bond, right? So please note this point, है ना? हमेशा ध्यान रखना है इस चीज का, and you are going to see the some questions related to this topic as well, and then utilize this concept and you can easily solve this question. Now, next is you have to identify beta. Let's discuss some more question with you, right? So this point must be remembered. Just give me 1 minute. I'm going to discuss some more important question with you related to this topic only, right? For example, many time questions were coming just related. For example, what happened? Just let me, yeah. For example, some questions were coming like what happened when we treat, right? What happened when we treat formaldehyde, right? Formaldehyde and formaldehyde, right? 2 mole of formaldehyde, right? In presence of concentrated NaOH, right? In the presence of concentrated NaOH. Then formation of what takes place, beta? Tell me fast. When the 2 mole of formaldehyde is treated, then the formation of A plus B takes place. Just identify this A and B. What is A and B here? Like that question. So this question is basically from which topic, beta? This question is from Cannizzaro reaction, and we know that in case of Cannizzaro reaction, the formation of alcohol plus sodium salt of carboxylic acid is formed. So in this word form, what is A here, beta? That is CH3OH. And similar way, what is B here, beta? That is HCOONA. So just note one thing. Just note one thing here, na. For Cannizzaro reaction, for Cannizzaro reaction, what is the essential requirement for Cannizzaro reaction, beta? For Cannizzaro reaction, alpha hydrogen must be absent. Must be absent. So alpha hydrogen must be absent, right? And similar alpha hydrogen must be absent, and similar uh, formation of two things, that is, and this reaction, this is the disproportional reaction, right, in which disproportion, that is, both oxidation and reduction of the same compound will take place. So this is the disproportional reaction also, right? So this is all about the Cannizzaro. But if you are talking about the aldol condensation, we get the two different possibility. Like in aldol, two type of aldol we have, like normal aldol, or we say aldol condensation between same aldehyde. Okay, so aldol condensation between same aldehyde or ketone, and the another one is, that is the aldol condensation between different two groups, right? Two different groups, also known as cross aldol, also known as cross aldol. So, in case of cross aldol, we get the mixture of product. What we get, beta? We get the mixture of product. Like when we treat this SCHO with CH3CHO, right? In presence of dilute NaOH. Then in this, four possibilities are there. The first one, either this will act, if I'm taking, instead of SCHO, if I'm taking like CH3, CH2, and CH, right? Let me write again. That is CH3CHO, and this will be CH3, CH2, and CHO. Propane, propanol, and ethanol. So there are total four possibility of product. How? Maybe this CH3CHO act as a nucleophile. Okay, so in this we get product number one. Maybe this one act as a nucleophile, then we get product number two. Maybe this is also happened कि one molecule of CH3CH act as a nucleophile and one act as electrophile. So by combining these two, we also get one product, that is product three. And this will also happen because same molecule of propanol act as a electrophile and nucleophile. Then we'll get another product, that is four. So total four product we get in case of cross aldol. Cross aldol means what, beta? When the two different aldehyde or ketone were taken. So whenever two different aldehyde and ketone were taken, we get the mixture of product, right? And when the two same aldehyde or ketone are taken, then we get the aldol. So these are the from aldol condensation. So always try to learn this. Why, I'm explaining this topic after PYQ questions. I'm observing most of the questions were coming from this topic only. So I'm just summarize you that how will you remember this in a short way so that you can able to solve question related to this, right? On the same basis, one more important thing is, that is that is formation of aldehyde and ketone, right? That is whenever, that is CO, whether it is aldehyde or ketone, no issue. For this, for both aldehyde and ketone, this reaction is valid. When this is treated with H2, nickel, platinum, when these are treated with H2 nickel platinum, LiLH4, or NaBH4, right? When this is treated with H2 nickel platinum and NaBH4, then always alcohol will be formed. Then always remember what will form, beta? Alcohol will form. But when this is treated with, NH2, let me write NH2, NH2, right? Or we say zinc amalgam, then alkane formation takes place. This is known as Clemson's reduction. We already discussed, questions were coming from this topic, right? And this is known as Wolff-Kishner. That is Wolff-Kishner reduction. Wolff-Kishner reduction, right? So these point you must be considered. This point you must be learned before you're going to solve this question, right? So, for example, let me share the question with you. This one, this was nucleophilic addition. Huh. Experimentally reducing functional group cannot be done by which one of the following reasons, like NaNH2. Okay, this cannot be reduce the functional group cannot be done by this. One question is also now that is from Clemson's reduction. This is mass type of question, right? Yeah, this one. That is the Hofmann's degradation, Clemson's reduction, Cannizzaro reaction, right? So for Clemson's reduction, now Clemson's reduction, right? We use this region, that is Zn, Hg and HCl. So questions are generally coming from this topic in this manner as well. Okay. Okay. Next question where you use this concept is yeah, this one. That is which of the following condition is the reaction not acetophenone is formed. So this is a nucleophilic addition reaction, right? So this is the nucleophilic addition reaction, and in this also, when aldehyde or ketone is treated with HCl, then the addition reaction will take place, right? And this will already be discussed, right? Yeah. This is that is when the acid chloride is treated with NH3, then the formation of amide. So this concept is also important. So please learn this. Make a note here and try to learn this concept as well. Okay. So whenever this is treated with the ROCl is treated with NH3, then the formation of ROCONH2, that is amide, and Br2KOH formation takes place, right? And when the amide is further treated with Br2 and KOH, because we know that this is a Hofmann's bromide degradation. So whenever the amide is treated with Br2 and KOH, then the formation of this will take place. That is CH3, CH3, CH, CH2. And in presence of Na2 and HCl, the formation of this takes place. Right? So I hope this is clear to all. Having any doubt beta related to this topic, you can ask, right? So these all are the important topic that we are discussing today, right? In the aldehyde and ketone. Try to learn this all and try to, solve the question as much as you can. As the more number of questions you are going to solve now, you more learn the, small concept behind each and every question. And if you know how to handle the questions and how to identify the question, that is the which question is coming from which topic and like that, na, then you can easily solve entire chapter, right? So I hope this is clear to everyone. So let's end the today's session with this question only, right? And next meet in the next class where we're discussing some new chapters. Okay, so let's summarize this class and let's end this class with this question, right? All the best, and try to study and learn, and no, just study in a cool way. Okay, so don't get stressed and all. Just read it and just try to learn as much as you can. Right? Okay.